Hi guys, nice to have you back and warm greetings to the first episode of my next big model building project. And with big, I don't just mean the pure size of the model that I have in mind, but also in regards of the complexity of what I have planned. In this series, I once again want to take you from the very first parts or even the calculations up until the model is completely finished and really show everything that you might be interested in. Besides some very basic decisions, there are still plenty of questions unanswered, so be prepared for some surprises on the way. And you might ask, what will it be? So what I can tell you now is it doesn't have tracks, it has wheels and a lot of them. It's not an excavator, but it fits really well to one. And without further ado, let's just take a look at the trailer for the real machine. And here you have it. So this is the REXX from BIS Industries, this one that I want to build as a scale model. Before we start talking about the actual model, let's talk briefly about the real machine, so the real prototype. Unfortunately, there isn't really much information available about it, and as far as I know, this one has only been built as two pieces. So the first piece you can see here in the video, and the other piece is the one with the yellow reflector stripes, and as far as I know, these are the only two real size versions that have been built so far. Let's see what Google can tell us about this particular truck. So if we go to Google and search for BIS REXX, there isn't really much information that you can find about the truck. So the first one is a PDF datasheet that we will take a look later on, because it has some quite important information that we will need to build this as a model. And of course you'll find some videos. You can also find them if you just go straight to YouTube. And on the other hand, if you go to Google and search for BIS Industries, you can find BIS Industries. This is a company from Australia. They are mainly focused on mining and mining services. So mainly they have some equipment for hire and maybe also for sale. And as far as I can tell, they also do offer some service on mining equipment. And they also did develop some specialized trucks in the past, like the BIS REXX. So unfortunately there isn't anything to find about the BIS REXX right now on the website. Maybe they have cancelled the project, I don't know, but we will build it as a model because it's quite unique and it deserves to be replicated as a scale model. So what makes this one so special compared to other dump trucks? If we go further down in the video, and of course I will put the link to the video in the video description, so if you want to take a look at the video as a whole, of course just follow the link and watch it for yourself. So if we go further, we can see that this prototype is operational in a mine next to a big mining truck. I think it's a Komatsu, quite a standard design that you have seen numerous times. So if we take a look at both trucks side by side, you can see that the BIS REXX has a considerably smaller width, but it also has quite a small turning radius, which will come quite handy when we use the model on a parkour, since it is quite a huge model. And since I don't want to change the scale of the model, so everything has to be the same scale, I don't want to scale it down. So it has to work somehow on the model parkours. And before we talk about the model and how I have planned it, let's briefly take a look at the PDF brochure. The main two advantages of the BIS REXX compared to other mining equipment is as they state, superior fuel efficiency, so up to 40% less fuel is burned, and the increased range. The increased range is something that I wasn't aware of. The range seems to be limited due to the tires overheating from the big dump trucks, and since this one has considerably smaller tires, and also I assume it has a much greater surface area of the tires connecting to the ground, and there seems to be less friction, and therefore the tires seem to heat up considerably less compared to big dump trucks. But to be honest, I don't know this. So what is also quite important for me to build this as a model, sometime earlier I've read that the BIS REXX uses somehow standard truck equipment like axles and tires and etc. So this comes quite handy when building this as a model, because I really don't want to build everything from scratch up. So I would like to use some standard equipment for the model, like axles that you can already buy in model size, so we don't have to build everything from the ground up. Of course we will build many pieces from scratch, and also in quite a unique way, I guess, but this project needs to be finished at some point. So I will buy some components that will get handy. So this huge truck as a model, and in the meantime I let the video continue. So what are the main facts or the main standards that I want to use? So of course this will be in scale of 1 to 14.5. This is the exact scale of the excavator that you know from my previous videos, and this is also the scale that I mainly build models in. So I'm not a really big fan of switching the scale, because I don't think that it matches really nice, and therefore I want to stick to the scale. In fact, I'm pretty happy that this model has quite a small turning radius, because I want to use it on the model parkour, and it has somehow to fit, and therefore the small turning circle is a very nice thing. Also you can see the REXX in comparison to a Liebherr 9200, I guess, and of course this is quite a huge machine, but nowadays you get such a huge machines as a scale model mainly from Asia, and I also know some guys who have such huge excavator models, and I'm very interested to see how the BIS REXX will perform as a model together with such big excavators. So of course the model should be completely remote controlled, so you have remote controlled driving, steering, the bin will get raised, you have light, sound, and maybe some FPV, but I'm not quite sure, but I would imagine that it's very handy to see with such a huge model, like from the front bumper and the rear, when you do some tight maneuvering, that you have the possibility to view it from a remote screen. But we will see it once we build it. FPV will be somehow the more or less the last step. So yeah, we'll just see if we make it come reality. And how will this model be built? So let me quickly forward the video until we have a nice view. So here you can see how the bin gets raised and how the model overall is composed. So the main frame that you see down here and the bin, I want to build this completely out of steel or stainless steel and micro welded, so you can that you can see how such micro welded pieces are made. This is more or less the easiest part, I guess. And if we take a look at the front, at the cabin, so obviously some 3D printing will be involved here, because it's quite an easy technique nowadays to get such complicated parts. But I want to try to build as much as reasonably possible out of metal. And also such delicate details like the handrails and stuff and the ladder, I want to try to build them out of metal. Maybe some photo etched parts and like the handrail out of brass or even stainless steel and soldered or micro welded. We will see. As I said, not all questions are answered until now, but as we build, we will see how we will make it come reality. So the drivetrain, as you can see quite well in this picture, and as I have already mentioned it, the real prototype has 5 axles, and out of these 5 axles, 3 axles are steering axles. These are the first 2 and the last axle, and these 2 axles are rigid axles. So of course we will produce this one-to-one in the model. Also, if we take a look at the video, here you can see it very well again. The first 2 axles can be steered, those 2 are rigid. And here you have it, 5 axles, 20 wheel drive. So each wheel is driven, and this is what I want to show you. Each axle has double wheels on each side, so you have 4 wheels on each axle, which makes it 20 wheels in total. Talking about the drivetrain, the real one of course has a motor here in the center, the whole drivetrain. So in model making it's quite common for such vehicles to simply use 1 motor per wheel, but I don't like it. I want to have proper axles with differentials and not just 10 individual motors. So we will use 1 quite big motor, and of course I will use a brushless motor, but I want a sensored brushless motor. This means that you have a very precise rotation of the motor, but unfortunately I could not find any sensored brushless motor in the size that I want to use in this model. So we need to build something our own, or combine some components to get a sensored brushless motor out of a non-sensored motor. So you can be excited what we will come up to make this reality. So talking about the steering, in the model I want to use 3 different servos, so 1 for each steered axle. This makes it also quite easy to get the different steering angles that you will need on each axle. So also for the drivetrain I want to have some axles that can be diff locked, so that you can lock the differentials on all axles to get some even better off-road capabilities. And talking about the off-road capabilities, one main point is the suspension, and that's why we will take a close look on this suspension right now. So the suspension, talking about the suspension in scale models, the biggest problem is that the suspension is either often way too hard or way too soft. Reason for that is that the suspension on more scale models can't be adjusted, so you just stick to one level of hardness of the spring and deal with it for all the time. This is totally fine if the weight of your model doesn't change over time. But if you have a model like this truck, where the weight of the whole machine changes quite drastically once you put some load in it or you unload it, and the suspension either becomes too hard or too soft. Talking about how this is approached in real life, basically all trucks that use leaf springs for suspension, the hardness of the suspension cannot be adjusted. So basically the suspension is designed to handle the load once the truck is fully loaded. And of course it drives quite well then, but once it's unloaded, the suspension even on real trucks is often way too hard. So how is this addressed in real life? Many trucks nowadays have air suspension. This means that an air cushion is used as a suspension, and depending on how much load you have on your truck, you can raise or lower the suspension and put more pressure in the air bellows to get a harder spring, or you reduce the air and get a softer spring. And talking about the real machine, how is it done in the BIS REXX? As far as I can tell, it has a hydraulic suspension, so on each axle you have a hydraulic cylinder on each side. And of course we could do this in a model, but the way more interesting way is to use an actual air suspension, because mainly I haven't done it. I wanted to do it for quite a long time, and it's much more easy, I guess, to let the model handle well with air suspension, because you can adopt the amount of air that is in the spring quite well compared to hydraulic oil. Also, air can be compressed, so the air in a cylinder can use as a spring itself. So that's what I want to do in the model. I want to have a air suspension on all axles, and of course, once we have the air suspension, we can also control the ride height of the model. So if we go to coarse terrain, we can rise the whole truck, and once we are back on the street, we can lower the truck. Also, because we can control the amount of air that we put in the suspension, or the pressure that we put in the suspension, we can adapt quite well to the load that we can put in the truck. So even if we remove the load so that it hasn't anything in the bin, the ride height will be completely constant. We put in some dirt or so, of course the truck will lower, but we can address this by an automatic leveling system that increases the pressure in the air suspension to raise it back up. Sounds quite complicated. I don't have the best solution to this quite yet, but I want to address this in this model and try to get it built. So I hope, as I mentioned, not all questions are answered right now, but I'm looking forward to get some solutions for that. So, talking about hydraulics, or how the bin is raised, because that's more or less the only hydraulic function that we will need in this model. So obviously the bin needs to be raised, and to address this in real life, there are two telescopic hydraulic cylinders that I used, and that's also exactly the way that I want to solve this in the model. And also, as you can see quite well in this picture, you can see like these small pieces. These are the hydraulic cylinders for the suspension of the axles, but since I just mentioned I want to have an air suspension, therefore these cylinders will be not filled with hydraulic fluid but with air, so that we can use them as springs. So talking about the hydraulic, since we only have one valve, it's quite a boring system, quite a let's say quite a simple hydraulic system. And to make it a bit more interesting, I have in mind to incorporate at least an electronic pressure monitoring to see on my remote what pressure is currently used to lift the bin. And also, as you can see, the bin is raised with two telescopic hydraulic cylinders. We will see if there are any on the market that suit our needs, or if we need to build some by ourselves. So talking about the electronics, as I have mentioned, I have quite a big brushless motor in mind, one that uses 6S, so that's about 22 volts. And also the motor driver that I'm planning to use comes more from the field of robotics, so it's more suitable for higher voltage, so we don't need to stick to 3S or something like that. But obviously once we reach 6S or something like that, we need a battery that supplies such high voltage, and as far as I can tell right now, there are more or less no batteries that we can use in the size that would fit the model quite well. So what's the solution for that? We built our battery pack by ourselves, not too complicated, and I guess it's also nice to see for you guys how battery packs are made and how one could make one at home. So we will have to build the battery by ourselves. Also, continue talking about electronics. One part of electronics are the lamps of the model, and maybe if you can see it here, it is more or less quite simple. So you have some headlights at the front, some beacons on top. Also here are some additional headlights on top, and there is somewhere here you can see it on the back. Now there's also a beacon on the back here, and I think for the beacons we will use something that is already available on the market, since the beacons that are available are very nice, especially the ones that I have in mind that I want to use. But for the headlights and more simple lights, I want to build them and develop them by myself, also because I think it's quite nice for you to see how this is made. So the last part about electronics would be some sensors. And there is something that I want to show you. Maybe you did notice this, maybe you don't. But here you can see it. This truck has a monitoring system about how much weight is put in the bin currently. So right now you can see there are 0 tons, so there is no load in the bin, and you can see how much, I assume, how much weight is put on each axle, or on the clusters of axles, like the 2 front axles and the 3 rear axles. And this is something I also want in the model. Not that it is reasonable. I'm also not quite sure if it is achievable to get something in the model, but it should be a goal. Also, to have such a monitor on the cab would be quite nice. So I think by now you have quite a good overview of this more or less ambitious project, as I would call it. As I've mentioned, I don't have solutions for all the technical problems or technical questions right now. I've been thinking about this model since last year, so since 2024, but it's far from done and far from solved. And so what do you think about this project? Leave it down in the comments. Tell me what you think about it, and also tell me what interests you the most in this project. So what do you want to see in close-up? What details interest you the most? And as usual, I would really appreciate if you leave a subscription, for you totally free and for me super motivating. And this way also you don't miss any future episodes and any updates on this build. So until next time, cheers.